Welcome to AI driven perception learning mapping for drones. Lecture 1, it's about introduction. Here we will motivate why we need AI and perception for drones. What are the objectives of this particular module? We will be introducing the student to overview of artificial intelligence in drones. We will talk about familiarize them in understanding the building blocks of the network and learning paradigms. We also talk about need for AI and visual perception. We talk about detection, tracking, semantic understanding aspect of it. How the generative AIs are used for understanding of the drones, right? And distributed AI for planning and decision control. Just give a conceptual understanding how it has been applied for different fields, right? Usage of drones for real world applications and deployment on edge devices. We also talk about the futures of artificial intelligence, how it is looking at changing the way autonomy can be brought in. When I say autonomy, autonomy of a single drone, autonomy of group of drone, what we call group autonomy or distributed autonomy aspect of it. Okay, this particular lecture give kind of a motivation for all these aspects. Okay, first let's look at different terminology. Many of you know about it, but it's just better to have a good connections when you say artificial intelligence, AI. AI is a simulation of human intelligence process by computer system. When I talk about human intelligent process, there are various processes are present. Learning, right? Learning basically to improve the performance of the experience. Moment I say learning, there are various ways in which people learn, right? Learning by experience, learning without seeing it, which is what we call prior knowledge, right? What we call meta learning, it's nothing but learning about learning, which basically one uses to regulate himself. Regulate what to learn, when to learn, how to learn. Then meta learning comes into picture. The meta learning is learning in a cooperative sense, right? In a collaborative sense, right? Or even in a competitive sense. Human learning is so complicated. Are we going to talk about all of this? No, we are going to talk about only learning by experience, right? Reasoning is very, very important. Why did you do it, right? Drawing a conclusion from my learning experience. And we talk about perception. Understand the scene using multimodal sensor. Human learning, if you look at it, visual, touch, right, and ambience. A classroom with teacher, without teacher makes a difference, right? Presence of a specific object in the scene changes the behavior of the object in the scene. So perception is more complex. It depends on time, depends on type of objects present in the scene, and depends on what activity they are trying to perform, right? Understanding that is more difficult. Problem solving. Any particular problem where you are trying to apply artificial intelligence to solve a complex task. Tasks need to be broken down into multiple subtasks. Once you break down them to subtasks, each task needs to be executed, and these tasks need to be executed sometime in sequence or sometime simultaneously so that you can achieve the complex task. So problem solving skill is also very, very important. The most difficult part is understanding, language understanding, right? Reading, writing, conversation in human language. The conversation you bring it in, it introduces an additional complexity. Emotions comes into picture. During different emotions, or the way person express himself differ. The expression also depends on how powerful he is in that language, right? So understanding when I say language understanding, I'm trying to bring attention here. I am not understanding just literal sense. I am trying to understand why he spoke, why the object spoke like that, right? Or why the robot is speaking like that, or why the human is speaking like that, right? What is his intention is very important. Finding an intention is the most difficult aspect of it. If I know the intention, I can handle what action I need to perform. Now, think about it, human drone collaboration, right? Human trying to give a command. Now, the drone need to understand the context in which the command has been produced. The context plays an important role. So, the scene understanding, the perception is a critical aspect. To really understand where am I, why that language was spoken on that particular context to take a necessary action, right? If you see, that connects to reasoning back. Understand the scene, understand the language, I have to reason out my action space. And that is the experience it has to learn so that he can perform complex tasks. These all the 5 qualities are interconnected, right? But when we talk about machine learning, we talk about the learning alone, learning by experience alone, right? Yeah, computer systems learn from the data to improve the performance without being programmed for every role. Basically, it's trying to find pattern in the data, predict the outcome on the data, right? But when we say deep learning, moment when we give machine learning, we are giving a data. Deep learning where we are not going to give, still we give the data, but here the data is more extracted feature which can be related to the particular task. When we talk about deep learning, we are not going to extract the features. We are not going to say these features are very important and all this. We are just going to give the data, raw data. Let the network identify what is the feature that it has to extract from the scene and use the feature to learn complex patterns from the data, right? If I have to put artificial deep neural network, deep neural networks is also an artificial neural network with many layers to learn complex pattern from the data. If I look at a key building block of this deep learning, neurons, right? Every layer will have neuron. This is nothing but the fundamental building block of the neural network, which receives signals and activate next neuron, what we call next unit. Weights are nothing but strength of activation forwarded, which is learned from the data. Activation function, which is a nonlinear function that defines the nature of the neuron, how the neuron is going to behave. The learning paradigm, the process in which the weights are getting updated is what learning paradigm we are talking of. Then there are popular architectures. Shallow neural network we talk about, which is generally used for general tasks like prediction, classification, time series forecasting if I am trying to interested in weather prediction, right, or rain prediction, or stock market prediction, right, or sequence prediction. Classifications like when there is a signal from which we extract a data and I can identify whether there is a crack or it's not a crack, where is the crack, all that is possible using shallow neural network. Convolution neural network process the image and video data. If the data is not signal, it is an image now. How do we process the image to extract the same general tasks like prediction and classification? Recurrent neural network, there is a feedback structure into picture. How this feedback structure helps the network to find the temporal patterns in the data. Generative neural network, like generative adversarial neural network and diffusion models, how they can generate data in unseen domain, right? Now, with this terminology and some building blocks. Let's look at the motivation for why AI needed for drone perception, learning and mapping. Let's look at an agriculture, a precision agriculture, right. If you see in the small figure, a drone which is flying in a scanning pattern, right, what we call line scan, it goes up and down, right, in a path, trying to get the image of the farm. It trying to give higher resolution information about the soil mapping. When I say soil mapping, I am trying to understand moisture content, understand micro and macro nutrient present in the soil, which is going to help the plant to grow. If the plant is already there, then I need to understand how the chlorophyll content, is there any pest affecting the region of a farm, how the plant is growing, how the yield is, right. I have to analyze all this. We can use the drone for entire life cycle of the plant, from seed to produce. The entire life cycle can be monitored using drone. That will help in precision agriculture. Minimum usage of water, minimum usage of pesticides to maximize the production from a unit area. That is one area where drones are heavily used, right. When I talk about mapping, right, I can map larger area of, right, I can map entire square kilometers. I can create the map of it using the drone. The large area mapping is very, very important for city planning, right. Or if there is a natural disaster, I need to understand how much of region is got destroyed. I can analyze and identify how much I have to plan for restoring that region, right. So large area mapping is another interesting area where drones along with AI has been widely used to identify the affected region. I can use drones for surveillance purposes, heavy traffic, right. I can identify incoming traffic, outgoing traffic and understand the flow. Is the flow get affected? Why it got affected? We can do it very easily using drones. I can do a survey, a topographic map generation, right. I can fly the drone, I can create a 3D mapping of the drone which we can use, and that will be used for planning purposes. If you have to construct a road, if you just see here, we have the digital 3D representation of close to half a kilometer region. Now this digital information helps me to plan where to construct the road, how the slopes are, based on the slopes how do I plan the drainage system, right. I can even identify the changes. When I did it 6 months back or 1 year back, now how the vegetation growth is taking place or how the building growth is taking place, how the urban area is expanding, right. I can get all the digital information very easily using aerial survey. I can monitor the power lines. I can use it for infrastructure monitoring, right. So how the power lines are, is it sagging, where there is a problem, we can identify these power lines and monitor the power lines. We can identify the critical infrastructure, safety of the critical infrastructures, right, whether there is a crack developed or whether there is a damage, how bad the damage is, or for all these critical areas where it is very difficult for human to go and inspect. Of course, one can use for disaster management like firefighting, right. You can identify the changes that took place because of the flood during the rainy seasons, assessment how much of a farmland got affected so that we can understand how much of the yield is gone, what kind of financial pressure on the government to help the farmers to recover. All analysis are possible, right. Swarm of drones, I mentioned it can be used for protecting a particular region or protecting a specific convoy which is going on the highways and so on and so forth. Now let us look at one by one. Let us look at precision agriculture. I am just showing an illustrative figure, right. For example, I can just as I mentioned earlier, when I go use the drone to fly over a farmland, I can look at entire plant life cycle, right. I can just look at what kind of pesticide or fertilizer needed, how the seeds can be spread across using drones, right. How you can identify the growth of the plant, produce of the plant, how much is produced, all that is possible, right. Suppose if you are talking about vertical crops like cash crops which is being there, you may have to spray in a specific region. It is very difficult to access from the top or anything. You can think of a ground robot which is carrying a lot of spray material whatever required. You can have a drone which is tethered drone connected with respect to the ground robot, go and spraying the specific region is possible. You can also have cameras which can look at the spectral informations to understand the diseases, understand the soil characteristics and help in precision farming. What advantage you have by using drones in agriculture field? You get a high spatial resolution data. Whenever we use a spectral camera, we can get a high spatial resolution. We can understand the soil nutrient, micro, macronutrient and soil moisture contents, right. We have a flexibility in data collection. We can collect the data. One can use a satellite, but it collects once in a while, right. You can have a flexibility. You can have multiple temporal time that in which it goes and you can augment it. That flexibility in data collection is there. Improved spectral resolution. Because you are putting a hyperspectral camera, you can have a high spatial and spectral resolutions are also possible. You can have a reduced atmospheric interference because it is very close to the ground. The effect of cloud is not going to be there. So the information that you are collecting is much more accurate. You can validate it on site. You can also process the data very rapidly. You can look at crop and vegetations monitoring in the entire life cycle more precisely. The cost is reduced, right, and you can customize data collections are possible, customization with respect to the crop that you are growing, right, that is possible. And pest manifestation happens in certain period of the life cycle. You can collect data during that period to identify early diagnosis, right. So precision farming is easier with drone on agriculture domain. Now large area. When I say large area reconstruction, you think about it. If the city wants to expand and a city wants to understand how they need to construct the roads, how urban area is expanding, a drone flies over that particular region and you see it's collecting a data. It's a video data. I am just putting it as an images at a different point. And I can use this entire image and build a nice 3D map. Once you have the 3D map of that region, planning becomes easier. You can also identify the changes in that region. When I did this flying over that particular region last time to this time, let us say in summer when I went or post rainy season when I go, how much of the vegetation has come in that particular region, you can identify very easily. Right? How much of changes in terms of structure can also be identified easily. And this act like a high definition maps, right, which will be useful for planning. And it can also create digital surface map. I will talk about it in details in subsequent slide. And it creates a virtual reality, right. I am creating the entire region in virtual space, so that you can walk through at a different time, rotate and see at a different angle and understand where this development is happening, what is happening, right. It helps us a lot in terms of large area. I mentioned about digital surface map, right. DSM is very, very important, not just only for planning purposes, it is also useful for navigation purposes or targeting, target location estimation. I wanted to know precisely the latitude, longitude of the object in the scene. If I have the DSM along with the image, I will be able to do. The color gradient helps in visualization of the terrain changes in the DSM map, right. The building heights, the topography, everything is possible. That can be generated very nicely using drone. DSM can also be used for urban planning, and it can also be used to analyze the height of the building, right, and then you can identify if there is a violations in the structure, right. All this is possible. You can also identify the runoff modeling. When there is a rain, water flows through the surface. Where do we need to construct the runoff, or where do we need to construct the drainage such that water is not getting stagnated. So runoff modeling, drainages are possible. You can do line of sight analysis, telecommunication, because the surface map is there. Where do we need to keep the towers, which will help in line of sight communications, right? All these analysis are possible. You can do a forestry canopy structure mapping. How much is the forestry region, the density of that, right? You can map and analyze the expansion or shrinkage of the forest. You can also use it for flood risk modeling. If there is a heavy rain in that region, the runoff will go where is the likelihood of water gets stagnated. All that simulations are possible. If this flow is high, how much of surface can be eroded due to this water forces. Those kind of simulation requires the digital surface map. Drones can be used to generate such a digital surface map, which can further use for these analysis. Now look at the aerial surveillance aspect of it. I wanted to detect the traffic, and I want to understand the number of vehicles or traffic density at a specific road. Suddenly I see a congestion. Why the congestion happened, right? What are the reasons? Is there any accident in the road? Because of that there is a diversion and then traffic density increased. The traffic is not flowing. Or if I want to understand how many cars enter one particular region and exit, all that analysis are possible. You can also do it in IR imagery. So what you see at the bottommost figure, you see a yellow dots. We are trying to zoom that region and trying to give how the vehicles in that region can be analyzed much more efficiently. I can understand the exit road, how the flow in the exit road. Or I can do the multiple object tracking, right? So many vehicles are there. I wanted to know in that particular road, in a smaller region, how many vehicles are coming inside the region, going out of the region, right? If you think about it, it's like an entry point. You want to count how many cars are coming in and going out, right? You can identify. Not just that, you can identify the traffic density in that region and flow rate over a period of time. Or you want to lock onto a specific target and you can continue to track the target, how the particular vehicle is going in that region. You can also identify rogue vehicle. Suddenly a vehicle lose direction and start moving in arbitrary fashion. You can identify those vehicles very easily, right? So you can mark the region and you can understand what is coming in, going out of the region, or you can understand the entire traffic density. For example, disaster, I am just showing it as an animation form. If there is a fire, you are deploying different drones to mitigate the fire. The challenge here is, first you need to identify where there is a fire. The fire not going to be kept constant, they are going to keep growing over a period of time. The growth depends on so many factors, It depends on the carbon content. It also depends on the water, right, moisture content in this region, and that's how it spreads. And you also have the wind plays an important role. A large fire can be made into multiple small fires further by just because the wind you carry for the nearby dry region picks it up. How many drones can work together? For a larger fire, single drone alone cannot contain it. You may need too many drones have to come into picture. How much time it takes for someone to quench this fire? You wanted to understand how the fire is spreading, when it gets detected, how many of them are working together. If you see here, this once it gets detected, how many drones are acting on it, rate at which they are quenching that particular fire. Sometimes you may have to, two of them have to converge. More drones doesn't mean that you can quench faster. You will be wasting the resources. So you may have to allocate optimal number of drones for quenching the fire, which requires the size and estimating the region of spread, right? Rate at which is spreading, all that affects the decision making capability of the drone. So who will go where, which team will quench, which team will go and search for fires in other directions plays an important role. So distributed AI plays an important role when you want to handle large area fire problems in a forest region. It is very difficult to access it. I am assuming that there are mechanisms through which you can just quench. You can just put a chemical, or other means in which you can drop and reduce it. I am just trying to give a philosophical understanding of how this can be utilized. Now we see different applications. We look at why AI needed for these particular problems. Let us look at aerial perception. Operational challenges comes into picture, right? For example, you may have electro-optical sensor, right? You may have an infrared sensor looking at the same region. You may have to do the detection. You may have to segment the traffic, right? Optical shows different features. IR might show the thermal characteristics of it. There is a common feature, edges are same in both, but semantics is present in RGB, whereas semantics is lost. Thermal characteristics present here, but that is lost here, right? For example, the car is parked for a long time or just parked. You can make a difference looking at IR. The engine was on, it is hot, you can identify. But in RGB, you can just say it is there, but you cannot say whether it is just parked or parked for a long time, right? So those differences is possible when you combine these modality together. The clutter operation comes into picture. The environment may be too much cluttered. The domain is not the constant. Domain might be changing. Daytime, nighttime, right? Or different locations can come into picture. In the night time, some places were highly well lit, well illuminated. Some location may not be illuminated. Different seasons of the year comes into picture, right? Sunny, summer, winter, rainy seasons. How these objects going to look like in the sensor domain, sensor spaces plays an important role. Sometimes absence of data itself. Certain specific objects may not be there in our data. How do we handle such kind of scenario? Absence of data in particular sensing domain may not be there. I may have it in RGB, but I may not have it in IR. What will I do? Right? I may have a multiple sensors like optical, IR, hyperspectral. I may have very few samples. Sometimes some samples are not even present. Domain or sensor shift will take place. Domain, what I meant is rainy day, sunny day, or day or night will change. Your image quality may not be good. You may have to enhance the image. For example, when there is a fog comes into picture, smog comes into picture, it affects the way the reflected light pass through the environment and comes to the sensor. That affects the quality. You may have to see it at longer range with a higher zoom. Small vibration will also cause pixel shift, right? These are some challenges comes into picture. Again, when I say decision challenge, which sensor to use in what domain? How these sensors going to cooperate or coordinate? When I say cooperate, they are going to share the informations, right? So for example, in the SpaceNet-6 data set, you have synthetic aperture radar image, you also have electro-optical image of the scene. These are two different sensor domains, seeing the same information, right? How they reflect the same information in their own modality. Variations will be there. How I'm going to use the complementary information and common informations to understand the scene more effectively. That's going to be a bigger challenge. As I mentioned earlier, IR also comes into picture, right? Can I fuse these information to give a better representation of the scene? SAR and RGB and IR, all of them being present, can I just create a composite image to understand the scene better, right? That's where AI comes into picture to understand the common modality, complementary modality, missing informations or samples is not present in one domain and another domain, how to transfer the knowledge from one to another, for which we need AI. Data absent is the biggest problem, missing data. I may not have a specific data, right? I may not have lot of information about the helicopters, different helicopters in the scene. How do I use generative AI or a simulation mechanism to create synthetic data or generated data, use the generated data to learn and make sure that the learned from generated data is performing better in real scenario. Simulation to real is always a gap. Generative to real is also there is a gap. How do we handle this gap to perform better? Slant angle perception comes into picture. I mentioned in the beginning, you can see it vertically down, you can also see it in a slant range. How are you going to handle it? Non-availability data, fewer sample, some of the future classes going to be present in the scene. I have only textual information about the class. I don't have the 3D image so that I can create it a synthetic, or I don't even have a single sample in one sensor domain. How do I use verbal description about that particular class to learn and predict them when it appears in that particular scene, right? Not just that, you may have to explain what you understood. It's very, very important. In a summary, in this particular lecture, we talked about different applications where AI can be used with the drone perception, mapping, right, and control. We also saw why AI is needed for aerial perception planning, what kind of challenges you will have in multimodal perceptions, right. In the next lecture, we will talk more about historic overview of and advances, and we also discuss about the challenges ahead beyond this course, what one can take it up and do research. Thank you.